My amazing students, this is Mrs. A, and I love math. Today we're on lesson 62 in your Saxon Orange book, and we're talking about square roots, higher order roots, and what do we do with evaluating pluses and minuses. So this is a theory section. We have a lot of theory that involves our roots, and so we're going to have to learn and memorize these principles and theories that we have to have because of ways that things have become understood across mathdom. Okay, we all look at things the same way. That's what makes math standard and what makes it easy to learn. Okay, so we have 4 times 4 is 16. Everybody would agree with that. Square root of 4 times square root of 4 is 16. So we would agree that 16 has 2 square roots. Okay, there's 2 square roots for 16, 4 and negative 4. However, all across the world, we have come to accept that when we see this symbol, square root of 16, we're not looking for 2 solutions. We're looking for 1. The square root of 16, this radical sign with something underneath it, has come to be known as the principal square root, or the positive of the 2 square roots. So if I wanted 4 out as the answer, I would put square root of 16 because although 16 has 2 square roots, positive and negative 4, all across the world universally we have come to accept that when I see that radical, that means the positive of the 2 square roots. Okay, so that would be 4, and then if I needed negative 4, I would put the negative outside, meaning the opposite of the principal square root or the positive square root would be the negative of the 2 square roots. So we know that the square root of 4 is 2 because 2 times 2 is 4. And because it's a radicand that we see on the paper, we know that that means the positive of the 2 possible square roots. If we wanted to get out negative 2, we would put a negative in front of the square root, meaning the opposite of the square root of 4. So that would be negative 2. Now, definition, if x is greater than 0, which means it's a positive x, then the square root of x is the unique positive real number such that the square root of x squared is x. Now, note that in our book, there's a little note. In our textbook, we will always have a positive radicand. We're always assuming that this is called, underneath here, that's called the radicand. That will always be positive in our textbook. Now, later on, you'll learn about what happens when that's negative. But right now, in our book, we're going to always treat that as positive. So they're stating that now so they don't have to say if x is greater than 0. All the way through the textbook, they want you to understand that in our textbook, it always will be 0. Okay, so here we have an extension of this rule. So our rule is the square root of x squared is x. So here we have the square root of 2 times the square root of 2, which is the square root of 2 squared is 2. And the square root of a times the square root of a is a. And the square root of x minus 1 times the square root of x minus 1 is x minus 1. Square root of 2.42 times square root of 2.42 is 2.42. Okay, so on this one, we're taking the square root of a counting number is either a counting number or irrational. We learned that in lesson 61. So if I take the square root of any counting number, remember counting numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 blah. All right, then I will either come out with another counting number or an irrational number. So if we do square root of 18, square root of 18 is not a perfect square. Since square root of 18 is not a perfect square, we will get an irrational answer. Now remember, irrational means that this decimal number goes on and on and on forever. It never stops and it never repeats, like pi. Okay, so when I put this into my calculator, I get Square root of 18 is 4.242640687, but that's only the first part of it. That goes on and on forever, never stops, but my calculator can't hold all of that. So we get the approximation, and then to 5 decimal places. Well, let's see. This would be 1, 2, 3, 4, 5 decimal places. So then we look at the number after it is a 0. So that means we can just cut those off and we don't have to round up. So that would be the answer to the first example. Okay, so then the next example says give me both square roots of 10 to 6 decimal places. All right, when I put the square root of 10 in my calculator, remember, 10 has 2 square roots. When we see the radical sign, that just means to give the first one the positive one. But notice there's no radical sign in this example. Both square roots. Okay, no radical sign. So we click it into our calculator, square root of 10. We get 3.16227766. We realize that this goes on and on forever. We are to do it to 6 decimal places. So 1, 2, 3, 4, 5, 6. This is going to be our last one when we round. But the next one is 6, which means we round up. Therefore, I'm going to change this 7 to an 8 and drop off the other. So this would be the correct answer. But it said, remember, both square roots. So plus would be one of them. The other one would be minus 3.162278. Now let me show you that in math sometimes we get a little bit lazy and we put plus and minus in front and it means both of them. So that's a quick little shortcut. Okay, so which numbers are going to have square roots that are counting numbers and which numbers are going to have square roots that are irrational? To know that, we have to know what our perfect squares are. So we're going to learn our perfect squares up through 20. And you should memorize at least those up to 15, but it would be helpful to know them all, right? So 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. So now, if I know those perfect squares, then I know that if I see square root of 25 underneath a radical, that's just 5. And I don't have to worry about doing any other kind of math, okay? 7 squared is 7 times 7, which is 49. 8 times 8 is 64. I was about to put 16, guys. 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is one that I've got to go look at because I don't remember. This is one I need to memorize. 14 times 14 is 196. 15 times 15 is 225. I'm pretty sure. I'm going to check it though just to make sure that I got it right, and I did. 16 times 16, I'm pretty sure is 256, but I'm going to check it just to make sure. Yep, that's right. 17 times 17. I want to say it's 289, and I'm right. I need to work on these a little bit too. 18 times 18, I don't know. 18 times 18 is 324. 19 times 19, I don't know, is 361. But 20 times 20 is easy. That is 400. Okay, so I've got a couple of these that I should learn. But if you don't know at least those up to here, all of those, you should memorize all of those. Okay, these are nice to know though. You're going to see 16 squared a lot. That's why I knew that one, but I didn't know these because they're a little bit more obscure. You won't use them as much. But the more that you know of those perfect squares, the faster you're going to be able to do a lot of your problems, because these are numbers that are used a lot in problems, especially through 15 squared. Okay, this one's a fun one. Determine between what two consecutive integers square root of 10 lies. And we're supposed to do this without a calculator. Okay, well, I know that the square root of 9 is 3. And I know that the square root of 16 is 4. Because I know these two things. Shouldn't square root of 10 be somewhere in between square root of 9 and square root of 16? Yes. So I could say the square root of 10 is in between, is less than 4, but greater than 3. So I can solve that without ever having to go to the calculator to find out what the square root of 10 actually is. Okay, so now we're starting to move into higher roots. And the first one we're going to deal with is cubed roots, because we're going to be working a lot with cubed roots. The cubic root of 8 is 2, because 2 cubed is 2 times 2 times 2, and it is 8. Therefore, the cubic root of 8 is 2. But notice, in cubed roots, we are allowed to have a negative number under the radical. Okay, so we're going to find out later on that odd roots like 3, 5, 7 are able to have a negative underneath. Because look, if I do negative 2 times negative 2 times negative 2, that's 3 negatives, not 2 negatives. And they don't cancel each other out. The first two will, right? Negative 2 times negative 2 is positive 4. But then a positive 4 times another negative 2 is going to be a negative 8. So negative 2 cubed is negative 8. Therefore, it's legal to have a negative underneath the radical. And the cubed root of a cubed root of negative 8 is negative 2, because negative 2 cubed is negative 8. So when we have odd roots, 3, 5, 7, 9, etc., we are allowed to have negatives underneath the radical, because the power can be negative. Okay, if x is a real number, then the cubic root of x is the unique positive or negative real number such that the cubic root of x cubed is x. So here, the x can be positive or negative. All right, so when we're talking about fourth roots, what do you think is going to happen? Remember, when we have odd roots, like 3, 5, 7, 9, we are able to have negative numbers underneath the radical. But remember, with square roots, that we define them only as the positive radicands down here. So, now what do you think about fourth roots? Because those are even roots. If x is a real number, then the fourth root of x is the unique positive real number, such that the fourth root of x to the fourth power is x. Okay, so here again, we're going to have only positive radicands in this book for even roots. Okay, so here's an odd root, cubic root of 8. The cubic root of 8 is 2, because 2 times 2 times 2 is 8. So that's 2. The fourth root of 81 is 3. Because 3 times 3 times 3 times 3, 3 to the fourth power is 81. Therefore, the fourth root of 81 is 3. Because can you see the 9 times the 9? We know 9 times 9 is 81. And then the cubic root of negative 27 is okay, because negative 3 times negative 3 times negative 3 again is negative 27. So those are higher roots that we're going to be working with. Okay, so here we're looking at the last portion of this section, and we're talking about evaluating using plus and minus. We're going to learn how to evaluate expressions, but first we're going to talk about this type of an equation that has a 2 on a variable. These are called quadratic equations. So x squared is 4 has 2 solutions because there's a 2 on the variable. An exponent 2 means there's 2 solutions. So these 2 solutions would be x is 2 because 2 squared is 4, and x is negative 2 because negative 2 squared, or negative 2 times negative 2, is 4. So here we're going to begin to learn a little bit about these types of equations. Quadratic equations have the highest power of the variable is 2. And anytime that happens, we expect 2 solutions. So here we're going to evaluate some things. Okay, so here is our last example before we start our practice problems. Now, how would we evaluate this mess? Okay, so now first of all, we're going to start here. I'm going to say, okay, order of operations says that I have to square first. So I'm going to take the square, only applies to the number or the variable right in front of it. There's no parenthesis here like there is over here. So it's going to be 2 squared, which is 4, and then a negative 4. So this negative means the opposite of 2 squared, which is going to be the opposite of 4, or negative 4. Plus, now we've got negative 3 times negative 3. Since it's in a parenthesis, the square applies to the negative 3, and we get negative 3 times negative 3 is positive 9. Plus or minus means we're going to have 2 different numbers to evaluate here. The square root of 4 is 2. Okay, so this is how we do this. We're going to get negative 4 plus 9 is 5. Plus or minus, we're going to write down here, 5 plus or minus 2. This indicates 2 solutions, and we're going to have 5 plus 2 is 7. 5 minus 2 is 3. So these are the 2 solutions that we have. Indicated they're 2 because there's a comma in between them. So the solution, or the evaluation of this, is 7 or 3. Both answers are correct. Okay, so now we're on our practice problems. So the first one is square root of 17 to 4 decimal places. Well, I went to my calculator and I typed in square root of 17, and I got all of those digits plus a little bit more because I have a calculator that takes it out a long way. But that's still an irrational number, and that continues to go on forever. But I only need 4 decimal places, so let's go. 4, 1, 2, 3, 4. This is going to be my last digit in my approximation. I'm going to round it down because this is a 0. So those are just going to get knocked off, and I'll get 4.123 as my answer. Okay, then this one, we're supposed to tell what 2 numbers is square root of 27 between. Okay, well, square root of 27, the square root right before 27 is square root of 25. And the square root right after 27 is the square root of 36. So, between 5 and 6 is where I will find this number. So, between 5 and 6, because square root of 25 is 5, and square root of 36 is 6. Okay, now these are our next 2 practice problems. The cubic root of negative 27. Remember, when I have a cubic root, I am allowed to have a negative under here. So I'm going to say that's negative 3 because negative 3 times negative 3 times negative 3 does equal negative 27. So the answer is negative 3. Now I have the square root of 81 is 9. Minus the square root of 144 is 12. So I have a negative number, don't I? 9 take away 12 is a negative 3 because I don't have enough to take away the 12. So it goes into the negative numbers there. Last practice problem. So again, the negative 1 is not in parentheses. So this is going to be the opposite of a 1 squared. 1 squared is 1. So the opposite of a 1 squared is negative 1. Negative 2 times negative 2 gives us a positive 4. Plus or minus the square root of 9 is 3. So I'm going to go ahead and put these two together. Negative 1 plus 4 is 3, plus or minus 3. So I have two answers. 3 plus 3 is 6. 3 minus 3 is 0. My two answers are 6 and 0. We are done with lesson 62. And this is Mrs. A, and may God bless your day.